Managing Editor of Solar Power World, and I'd like to welcome you to today's webinar, Commercial Solar Design in NEC 2014, Meeting New Arc Fault Detection and Rapid Shutdown Requirements. Very hot topic, so definitely going to be lots of good information for you. Before we begin, we'll go over just a few house cleaning items. I'd like to mention that this webinar will be available after the presentation on solarpowerworldonline.com. It's a question we get a lot, so please know that it will be emailed to all registrants, so you'll be able to view it at your convenience. Secondly, there will be a question and answer session at the end of the presentation. It's a great way to pick our presenters' brains, so we encourage you to participate. You can do so by submitting your questions whenever they come to mind at any time through the presentation. Just type them into the GoToMeeting panel on your right. And lastly, we encourage everyone to tweet about key topics and discuss takeaways using the Twitter hashtag #SolarWebinar. So at this time, I would like to introduce our presenter. Today we're thrilled to have Claude Kolp. Claude is the newest member of Selectria's application engineering team. He has over 5 years experience in renewable energy systems engineering. Claude holds a degree in computer and electrical engineering from Wentworth Institute of Technology, as well as a master's in business from Boston College. Prior to joining Selectria, Claude worked with some of the premier engineering consulting firms in the space, with projects ranging from net zero energy home design to multi-megawatt systems domestically and abroad. At Selectria, Claude's focus is on technical education and leveraging customer insights towards supporting new product development. So we're very excited to have him here with us today to share his expertise. So Claude, go ahead whenever you're ready.
Great. Thank you, Kathy. So we're going to be talking today about the implications of rapid shutdown and arc fault detection as it relates to the various NEC cycles that you'll all be designing to. But before, I wanted to just take a moment and talk a little bit about Selectria Renewables. So for those of you that are not familiar with Selectria, we got our start back in 1989 as Selectria Corporation, focusing on electric vehicle manufacturing and design. And as you can see here, over the years, starting in 2005, we have rapidly increased our product suite to accomplish fulfilling the needs of pretty much the entire market segment here in North America, from three-phase central inverters all the way down to single-phase string inverters. Just recently, we have some new news. For those of you that haven't been following the news, Yaskawa Corporation out of Japan has recently made a move to acquire us. Although that transaction has not been completed yet and is scheduled to be completed very, very soon, we're very excited to have Yaskawa as part of our team now to help us move forward into the future with development abroad. So Yaskawa is one of the largest manufacturers of inverters in Japan, and we are actively looking to expand into new markets, and this is a very strategic move for us. So what does this mean for you? So there's a number of different things that this means. First and foremost, it immediately allows us to participate in projects that we were not capable of participating as a private company. Secondly, the warranty becomes stronger, with Selectria still remaining as a wholly owned subsidiary. We're still going to be manufacturing in the same locations, but it really just opens us up for greater potential to service our customers and help drive costs down for solar renewable energy projects across North America and around the world. So we have a large North American presence. We're based here out of Lawrence, Massachusetts, about 30 minutes north of Boston. But as you can see from the map, we have sales and service offices and partners across the entire United States. And we're actually starting to open up some service teams in Central America. So very quickly, our product lines that we currently offer range from our 3.8 single phase string inverters all the way up to our newest 1000 volt 500 and 750 XTM product line, as well as a full suite of combiners offering, specifically our newest addition, the Arcom combiner box that we'll be talking about in just a moment. So when we talk about rapid shutdown and arc fault, we have to take into consideration the different code cycles that we're currently seeing being primarily used here in the United States. So in 2008, the wild, wild west of solar design, there was no arc fault requirements, and some people say we're living in the danger zone. We've got these systems that don't have fuse serviceability, and we have no way to detect any kind of serious arcs. In 2011, we've added the arc fault requirement for systems on buildings only, and that language was edited in NEC 2014 to remove the on building portion to apply to all systems. In 2011, we also included a few servicing disconnects requirements. So that actually was a large move towards having breakers in our recombiners. And lastly, rapid shutdown is the newest the newest thing that we're seeing. Companies such as Midnight Solar have really taken a strong hold on that market for the residential side, as well as other companies that are focused on micro inverters or optimizers. So what does this mean? So the majority of the country is still operating in 2011 code based on the available data here as of August 2014. So in this map, you can actually see Massachusetts and I believe Nebraska are currently operating in 2014, and actually I think we've got Minnesota and a few others. But by the end of this year, there will be 18 states that'll have adopted NEC 2014, not counting the states that have local adoption. There are a number of different states marked with triangles here in this map that show local adoption. So we're going to talk about how to deploy arc fault detection and interruption for two types of topologies, specifically our central inverter matched with our combiner box and our three-phase string inverters with AFDI built in. So what does rapid shutdown mean? Rapid shutdown, as defined in the NEC, requires us to de-energize, not actually de-energize, but reduce voltage within 10 seconds to below 30 volts in a crisis situation. And the way that we are able to do that is by disconnecting our DC feeders. Now, those DC feeders need to be less than 10 feet from the array or within 5 feet of entering a building. The voltage and the power must be referenced to ground. So there's some implications with specifically how you go about implementing this with floating arrays that have no ground reference. But by and large, the rapid shutdown initiation has to comply with this 30 volt in less than 10 seconds. So what we have here is a central inverter deploying combiner boxes, and the dotted line around the subarrays represents a 10-foot boundary. So when we apply 24 volts to the smart combiner box, or the arc fault combiner box, we are, in a sense, activating the flow of electrons from the solar array to the inverter and producing power. And the concept is, if we're able to disconnect that power, we're able to deactivate the conductors, de-energize the conductors to the inverter. Now, the conductors within that 10-foot boundary are still live, but this scenario actually very adequately meets the intent of the code. So some people ask, well, what about the DC capacitors on the inverter side? Well, looking at this a bit more closely, specifically looking at one of our smart grid 750 XTMs, Selectri actually deploys DC contactors on their recombiner inputs. So looking at this play out one more time, if I were to deactivate or de-energize the smart combiner boxes, I would also de-energize the contactors within the inverter by disconnecting the power to the inverter. So instantly, I would be able to isolate those conductors and create a safe situation for our first responders in a crisis situation. Now, this does require you to disconnect two sources, both the inverter's AC power and the rapid shutdown disconnecting means switch. However that's implemented, there's a number of different ways, and we can discuss that further. On the smaller PVI inverters that don't have contactors, such as our PVI 100 here, we do have to have a bleeder circuit in order to be able to accommodate that 30 volts within 10 seconds. But most inverters, like our PVI, do this in less than 10 seconds. Specifically, the PVI 100 does it in 2.5 seconds. So this also complies with the intent of the code. When looking at three-phase string inverters, we've got the same subarrays with the 10-foot boundaries, but we have our three-phase string inverters mounted adjacent to, within that 10-foot boundary, either on a rooftop or on a ground mount, and those three-phase string inverters are equipped with AFDI detection. So in order to accomplish rapid shutdown, the only thing that is actually required is to disconnect the AC power to the inverter, and you will have met the rapid shutdown part of the code and de-energize those feeders. At this point, I'd like to talk to you a little bit about Arcom and really the reasons why we've actually developed the Arcom. Briefly here, you can see this, and you'll be able to reference this when you actually get the slides, but I'm actually going to skip over this, and I'm going to let Eric talk to you via the video that was taken at in San Francisco at Intersolar this year.
Hi, my name is Eric Every. I'm with Selectri Renewables. I'm an application engineer here, and we're here at Intersolar to talk to you about our Arcom, arc fault enabled string combiner. It's listed to $1699B and is available on the market today. It's available in 8, 12, 16, and 24 positions. Comes with touch-safe fuse holders and string-level arc fault detection. The advantage of string-level arc fault detection is that you're able to accurately detect arcs and minimize nuisance tripping, which then minimizes service trips to the site. The arc fault combiner comes with a DC vacuum contactor, so when an arc is detected, the contactor opens up and you've isolated that combiner box from the rest of the inverters. The inverter is still able to operate, you've just isolated that part of the array. There's DC current monitoring available in the inverters, such that when an arc is detected, the inverter is able to detect that the box is shut down, so you know to dispatch someone to site, look for possible damage, reset the box using the switch on the side, and then your system is back up and running normally. The DC vacuum contactor also allows you to comply with rapid shutdown requirements. So you run power to the box, and when a first responder needs to come to the site and may need to activate the rapid shutdown system, they de-energize all the boxes, all the DC vacuum contactors open up, and then all of the controlled conductors on the roof are then de-energized so that the first responders feel safe venting the roof and cutting through DC conduit. For more information, please visit our website at selectry.com. Thank you for your time.
So let's take a second and look at the inside of the Arcom. And my apologies for the technical difficulty with the sound. So here you can actually see the inside components of the Arcom. We have our positive PV output here. We have our negative PV output here. We have our touch-safe fuse holders. Our motherboard is actually behind this location that actually controls the contactor, which you can actually find here. And most importantly, we have our sensing devices located on the input of our touch-safe fuse holders for our strings. Now, this box is designed to take power in two different ways. Natively, it accepts 24 volts DC. It has an operating range of, I believe, 19 volts DC up to 23 volts DC, or sorry, up to 26 volts DC, and it has an optional 120 volt power supply. Now this is actually 120 volt native, but it's actually capable of going up to 277 volts line to neutral. And what this allows you to do is it allows you to run an AC feed with greater voltage drops. So you're able to run 120 volts and drop to 100 volts before this actually drops out, because the threshold on this power supply is actually 100 volts AC. This box comes in both 1000 volt and 600 volt rated certifications, and if you look here, there's actually a way to test the functionality of the box with this momentary test switch on the side of it. So what does the Arcom do in terms of allowing us to meet 690.12c? Well, we're able to accommodate the requirements for the less than 10 feet by design strategy and placing the combiner box within the perimeter of the subarray. We're able to use the onboard contactor to allow us to immediately reduce voltage from whatever operating voltage might be, whether it's 350, 400 volts DC, to zero instantly. And we're able to adequately provide the other requirements through just placements of placards and having the ability to be flexible with the placement, because we have an 8, a 12, a 16, and a 24. You're able to address the rapid shutdown requirements through the central inverter and the combiner box topology, and if you are to look at the TLs, by placing the TL inverters within that 10-foot boundary. One new change to the labeling requirements is that this particular rapid shutdown label needs to be reflective. I've had a number of different questions recently regarding this, and there was some confusion that all labels needed to now be reflective, and that is in fact not the case. It's this label in particular that is required to be reflective. So, arc fault detection. what exactly is an arc fault? And that's really what I wanted to try to show in this next video that you're going to see in just a second. It may not play, so we're gonna talk about these three drawings right here. If you'll consider for the moment a normal wire that has been compromised in some way, shape, or form, either through pulling through a conductor, or if we were to consider the wire actually being the connection between two MC4 connectors of an ill-manufactured or ill-assembled connector, we can have a compromised state. And during the normal operation, the fact that the wire has been compromised might not actually register right away. It might actually take a couple years. I have personally seen arc faults, series arc faults, occur in systems that are as old as 5 years old that had never appeared and manifested themselves likely through freeze-thaw cycles. But what happens is, over time, that wounded area will actually begin to weaken to the point where we actually create a flash. And when we have a flash, we've got a number of different things that happen. So we have the flash, that is the light. Then we have the blast, which is the ionized plasma and the material actually ejecting from that site, that arc fault site. And evidently temperatures can exceed 9,000 degrees in that instance. So we're gonna try this little tiny clip. Sound's not super important, but we go through rigorous safety training here because we have seen firsthand what an arc blast is capable of doing. And this is really typical of a 480 volt arc fault condition. And as you can see in this video, there is nothing left of those connecting bars that are inside there. Those sparks that are flying out at over 100 miles an hour and thousands of degrees. So we want to avoid that whenever possible. With an AC arc such as the one that we just witnessed in a controlled environment, it looks like it's pyrotechnics. But in an uncontrolled environment with DC, it can lead to a number of significant problems. So 690.11 actually defines what we're looking for when we evaluate the products that are capable of detecting an arc. And if we look here, the system shall detect an arc, and on the conductor, the connection, the module, or any system on every source circuit. We also need to make sure that the system is disabled if an arc is identified. Now, so this is actually going to lead to some more important points. And lastly, there has to be some way for us to be able to tell that there's been an arc and allow first responder to be able to help troubleshoot, first responder from a commissioning side, be able to troubleshoot the issue and not just walk up to a box and decide, well, this is a false positive, let's just recycle this box. So what do we look for in an arc? Well, arc fault detection circuitry essentially looks for noise in the system. So as you can see here in the blue, we have normal operation, and around 35 to 50 hertz or kilohertz, you can see the resident decibel increase of an arc situation. So one of the things that Selectria did in deciding to develop the Arcom is eliminate nuisance tripping. There's been a number of different publicized instances of arc fault circuitry going wrong, and Selectria felt it within their abilities and also something that we really needed to own, in that we wanted to own the system. We wanted to make sure that our arc fault combiner solution has been type tested with every single one of our central inverters to make sure that we don't send people needlessly out to the field for a false positive, a nuisance trip. So every nuisance trip costs money. Every truck roll is a big deal, and people actually become desensitized over time if things continue to nuisance trip. The other reason is we wanted to make sure that if there were any problems in the field moving down the line, that there's only one throat to choke. Selectria owns and only sells the Arcom box with our line of inverters, and we stand behind both the inverter technology and the Arcom product. Now, that is not to say that we won't eventually support other people, but right now, at this point in time, we believe that this solution, looking at the signal through every single string as opposed to a single sensor or multiple sensors, looking at aggregate strings or reflections of arcs off of other things in remote distances, is really the most prudent means of allowing us to deliver the greatest value and help the systems produce the greatest return on investment. So furthermore, we've got string level detection on every single string, which we believe is the most appropriate way to detect an arc. There are other technologies that use single sensors, like I just described, and we have seen that those sensors have actually had a number of nuisance trips. But not only that, but with this particular technology that the Arcom has deployed, you are able to identify in a 24-pole combiner box which combiner box is having an issue through the use of Soul Zone if you were to do subarray monitoring. And also, once you have identified that combiner box, there's an LED associated with every 4 strings that are being monitored. So from 24 to 4, I can now look at these 4 strings and know that if I deactivate these 4 strings and continue my commissioning, I'm able to get the system up and running faster and start producing revenue and generating kilowatt hours right away. So we've got the ability to quickly isolate the damaged strings and get the system back up and running much faster. And when you're actually out on the site for one of these things, it's not because of a nuisance trip. So as far as Arcom's ability to meet the intent of the code, we are listed to UL 1699B. We have the requirement to be manually restarted in the event of a nuisance trip or otherwise an actual arc fault condition. And the Arcom box has an audible buzzer and LEDs, and actually it has an auxiliary dry contact for those that are so inclined to use it. In my conversations with customers, I haven't found any that are that sophisticated at this point that are interested in using that, but I'd be interested to hear a question or a comment through the panel on the right from any of you that are interested in understanding how best to use that. So think these are some of the most salient points that I want to share with you. A lot of questions that I've received revolving around the Arcom combiner box have been about the inverter and combiner box integration. And I'm here to tell you that they are essentially standalone systems. They do not have to communicate with the inverter at all. The only way to tell deploying this particular solution, or even Solar Boss if you were so inclined, is to monitor your DC inputs to the inverter and identify a situation where 7 of the 8 PV output circuits are actually producing, the 8th was producing and is now fallen out, and at that point the data acquisition system would actually send out an alert alerting you that combiner box 8 is now there's something wrong with it. It's not necessarily an arc situation. Perhaps the contactor has gone, perhaps the 24-volt power feed is now compromised from a million different things. So perhaps a conduit splice has fallen down and sheared that conductor. Maybe we've blown a circuit breaker, what have you. The 24-volt power that is required for the Arcom combiner box and various other products such as Arcom is typically really hard to run for long distances in DC form. So what some people have discussed doing, and what we have discussed offering as a potential recommendation is, well, depending on your topology, you might be able to offer up a hybrid design situation where your combiner boxes are now more centrally located. You have an external 120 volts or 277 volt to 24 volt power supply centrally located, and you literally have 24 volts running 5 to 10 feet to each of these centrally located combiner boxes. Most people that have adopted this so far and have actually purchased this product and installed it have opted for the AC power supply. You have a lot more flexibility with voltage drop. If you're using terminal strips, you might be able to daisy chain some of these and have everything come from a single feed. It is extra conduit. It is a bit more work. However, most people have still opted for the 100 volt AC power supply. And as I said here in bullet point 4, if you have 277 volts line to neutral, you can drop a significant amount all the way down to 100 volts and still make the Arcom work. That is the beauty of that power supply. One thing to note is the just like any piece of electronics equipment, the combiner box has now gone from a piece of dummy equipment to having sophisticated electronics in it, and anything that has electronics in it is now more subject to heat. So it's always best to place these elevated up off the roof, place them in the shade whenever possible. Just like siding an inverter, it will only make things work better for longer. And it's always just a really good idea as far as an O&M perspective. The rapid shutdown disconnect location is something else that we always have a conversation about. The code is not very clear as to where that disconnect or rapid shutdown button should be located. So what we are telling people is to have that conversation with your utility, have that conversation with the first responders, be it the firefighters, a medic, or the police, and avoid a situation where your first responder personnel and the firefighters come to your site and decide this building has solar on it. We don't know anything about this, and we would rather let the building burn to the ground than risk saving it and losing life. And I cite Dietz and Watson. I think that's the most recent situation where this has occurred, just as an example. And lastly, I can't stress enough that the subarray level monitoring is your best means of detecting if you've got an arc situation out in the field. I see a lot of people compromising their ability to keep their systems up and running and understand exactly what is going on as far as the health of their system, whether there's an arc fault, whether it's underproducing or otherwise, by not having some of the tools that have been made relatively available from Selectria, from other inverter manufacturers, and through our third-party data acquisition providers. Data is the best way for us to be able to help troubleshoot any issues that you may have, and also help you determine how to manage your asset to its fullest potential. At this point in time, I'd love to take some questions. I know we've got some time, and I'm sure that there are a number of questions that people have.
There are, Claude, indeed. Thank you very much. Great presentation. So go ahead and take a second here to grab some water after all that talking, and we will begin with one of the lead questions here. So 690.125 code requires that equipment that performs the rapid shutdown shall be listed and identified. So someone's wondering who has certified or listed the rapid shutdown, and to what nationally recognized safety standard?
That's a fantastic question. So the rapid shutdown combiner box has been listed. It's developed using listed components. I don't believe that there's a UL listing or an IEEE listing for the rapid shutdown test at this point in time. We do, so Selectria Renewables is a satellite ETL test lab. We do all of our UL testing here, and we've also taken this particular box, our Arcom combiner box, and put it through accelerated life cycle testing, or called Hall testing. And we've seen this from a number of different people regarding different components that Selectria provides, and just questions from other different people. But as far as I know right now, the Arcom is compliant with all UL requirements regarding rapid shutdown and arc fault compatibility. I think the closest one is 1699B.
Excellent. Lots of questions about the Arcom here. So we'll move to another one. Do the Arcom boxes have residual current monitoring capability?
No, they do not. So that portion of the code is new for 2014, and some of the central inverters have that built in as an option to, and basically, so for people that don't understand what residual current detection is for, it's actually to combat what's called the ground fault blind spot. Now, the ground fault blind spot it happens when the current flows between our negative conductor and ground, and is not detected by our traditional ground fault detection circuitry. So our 500 and 750 XTM have that as an option that you can purchase. And the only reason that it's an option at this point is because the majority of people that are purchasing this product at this point in time do not require it. If it was a requirement across all NEC code cycles that we serve, it would not be an option, it would just be included.
Again, another question about the Arcom. Can it be mounted horizontally, such as on its back rather than vertically?
Yes, the Arcom box is a NEMA 4 enclosure, so it can be mounted flat on the roof. It's fully sealed.
Can the Arcom be offered as an AC combiner as well?
No. I think I would actually want to ask that individual a follow-up question, because I don't know where they're going with that. But no, the Arcom box is for the DC side of the system only.
Okay. I'm not sure if this maybe is where they were going, but they're wondering if the Arcom functions as a smart combiner. Are data channels for current voltage available for each string?
So at this time, and as far as I know, there are no plans to add current sensing to the Arcom box. It has current sensing for the arc fault detection circuitry only. So it is not a smart combiner box.
We'll take a break from the Arcom questions, although there are plenty more. So what if inverters are not installed next to the strings?
So in that case, it's likely that we're talking about a combiner box and larger central inverter kind of configuration. I'm only assuming that we're talking about commercial utility scale projects at this point regarding that. But in that case, the Arcom combiner box would be deployed within 10 feet of the subarray, and the output conductors would be run to the inverter location and sized for voltage drop.
Okay. Someone else is wondering, since an arc occurs in only milliseconds of time, how can a shutdown in 10 seconds be considered as rapid? I think that's a relevant question.
So the rapid shutdown requirement was written in such a way to not eliminate the opportunity to reduce the voltage below what most consider lethal voltage. When you start to get to 50 volts, things start to really hurt. But 30 volts is deemed manageable from a encounter perspective. So the rapid shutdown requirement was developed to allow people that are able to curtail the output with, say, an optimizer slowly, comparatively to an arc, to 10 seconds. When an arc is detected, the shutdown mechanism happens in fractions of a second. So there are kind of two competing abilities. So it just so happens that in designing an arc fault combiner box, it also has the ability to accommodate rapid shutdown.
I think that's a good explanation, Claude. Thank you. Kind of keeping with arc faults, someone's wondering, what happens if the arc fault is in the PV output circuit rather than the PV source circuit? Is that possible?
It is possible. It's less likely, but it is possible. So what typically happens there is, in general, most arcs resolve into ground faults. So if we had a series arc and a conduit on the output circuit of a combiner box, it would arc in its contained environment inside the conduit, and then it would eventually touch the metal conduit if it was a metal conduit, and it would likely create a ground fault scenario, sending a significant amount of current at that point through the ground fault circuit, and it would trip out the inverter. And also, there is a chance that you would also see that reflection back into the Arcom combiner box, and it would also turn off.
Okay. Question about, let's go with this one about AC power. Can the AC power supply be powered from the load side of the inverter breaker so that the AC disconnect serves as the rapid shutdown switch?
It's a great question, and it's actually something that we've asked ourselves here regarding residential line inverters. It's all about overcurrent protection devices and following the other rules. Is there a way to do that? Absolutely. However, the central inverters aren't currently set up to do that inherently, but typically if you had a ground mount system, for instance, and you had a piece of AC switchgear, you would likely also have usable voltage for your data acquisition system, your monitoring. You might have some protective relays that need to be powered, and in there you would be able to pull power from that. So it's not as clean a way as having ready-made terminals that you can actually just pull that power out, but the intent is there. And additionally, the way that the Selectria solution works for first responders is, no matter how you're powering the Arcom box, if a first responder pulls up to a burning building, they're going to do one of two things in most cases. They're going to either try to kill the power to the building completely, or they're going to, by pulling the meter, throwing the main disconnect, or going out to the actual power lines and disconnecting it there if they have the means to do so. In any of those cases, once the power is eliminated from the building, so long as the equipment is powered from the building, everything will de-energize, and it will create a safer environment for first responders.
Thank you, Claude. And again, kind of going back to the Arcom questions, when will the Arcom be available for use with the TL string inverters?
So one of the fundamental differences between a TL topology and the traditional transformer-based inverters is they require fusing on both the positive conductors and the negative conductors, because they are it's typically a floating system. So the AC is coupled to ground, but the DC side is actually floating, so it doesn't have a reference. And because of that, both sides need to be fused. And because both sides also need to be fused, they also both need to be disconnected. The Arcom box is currently not designed to do that. However, we are working on developing a smaller version of a rapid shutdown box for the residential line. Now, the residential line, the TLs, and even the three-phase TLs have arc fault detection circuitry built into them. So they don't need that component, but they still don't necessarily comply with, it's not feasible to mount them in such a location to comply with rapid shutdown. So the need for this rapid shutdown combiner box or basically rapid shutdown string level disconnect box is being developed. There are currently very few manufacturers that actually produce a dual fused, dual disconnecting rapid shutdown box. I think the only one that actually makes one for a TL at the moment as a listed product is Bentech.
And just to clarify, Claude, does the Arcom come with the rapid shutdown disconnect, or is that a separate item that you order?
So because of the various different ways that you can power the Arcom box, it's impossible for us to be able to offer that solution. However, I can certainly offer advice. What I would do, based on the feedback that and the research that I've done, is I would use a very low tech way of accomplishing the rapid shutdown sequence, using an AC feed to like a 30 amp disconnect, for instance, or a 60 amp disconnect. From there, you feed the power to your Arcom combiner boxes, and the rapid shutdown sequence would begin by flipping the AC power to the Arcom box out. And we recommend placing that in a location that can be readily accessible and seen by first responders kind of coming in. It's kind of like an airbag. You don't ever want to have to use it. You don't ever want to see it work. It's really meant for emergency situations. This isn't a maintenance tool. It is for creating safe working situations for first responders in crisis situations. So, and that's what a lot of people need to understand when they're thinking about this. How do I make it safe so that my building doesn't burn down? I don't want to give any first responder any excuse to not save my building, not save my project by placing this in a very inconvenient location. For instance, if anybody happened to have looked at one of the last publications from a different solar trade magazine, they might have seen a residential system with a disconnect, a DC disconnect mounted on the gable end of a house up about 10 or 12 feet. And there were some comments revolving around that particular image saying, this is not what we intended, this is not what the code was talking about. No, you don't need a tool to turn this off, but this isn't exactly convenient.
I know I'm throwing a lot of questions at you here, Claude. You've been talking for a long time, but I think we have time for just a couple more here before our webinar is over. So someone's wondering, does the Arcom work on floating arrays with regard to rapid shutdown? Does the break in both the ungrounded connectors of the ungrounded floating system? Does that make sense?
Yep, no, that makes sense. That's actually very much it's a similar question to the previous one regarding TL inverters. So TL inverters are floating arrays because they don't have a ground reference. So currently the answer is no. The Arcom does not work on floating arrays.
Okay. For the Arcom, is there a version that uses power locally via a DC-DC converter connected directly from the PV source so that you don't need the extra control conductors?
Currently there is not. However, it is something that we are currently evaluating. What happens is the power requirements are very, very low, and the voltage at 1,000 volts, 1,000 volt DC to 24 volt DC, the circuitry and the components in order to do that are not very mainstream, so everything's very, very expensive and rare to find. So we're actually evaluating trying to make that install even easier by looking at DC to DC conversion, but at this point in time, there's no option available.
All right, I think we have time for one more here. In your opinion, why are Solar Boss and Solectra Renewables the only companies to be offering an AFCI solution currently?
That's a great question. So Solar Boss was the first person to come out with the arc fault detection circuitry combiner box. Now, arguably speaking, their focus is on combiner boxes, and it took some time before we realized that it was very important for Selectria to also make their own. We are the only inverter manufacturer that has an arc fault combiner box, and we've done so strategically because we wanted to make sure that none of the nuisance tripping issues that we've seen flood the market are associated with the Selectria name and Selectria brand. And the only way that we could take control of something was very, very important is by creating the solution ourselves and owning that solution. I know that there are a number of other people developing adequate products to meet the market demand. However, one thing to consider is that just because you have an arc fault detection circuitry doesn't mean that it will not nuisance trip. Now, I keep on talking about nuisance tripping, but it's very important for people to fully understand that every time there is a contactor that opens and closes in an inverter or other externalities in the power distribution system, that creates noise in the line. And we already discussed that noise is what the signature is that we look for in order to identify an arc. So if we have other things operating inside of an inverter that are creating those noises that resemble an arc, then we're going to have a lot of problems. The technology that Solar Boss has deployed is slightly different than what is used, for instance, today in a TL with a single CT. But I think that the market has scared a number of different manufacturers from considering making something that they didn't fully understand, and I think that people are proceeding very cautiously with releasing products, making sure that when they do so, they release it and it is a successful product, which is why Selectria only sells its Arcom box with Selectria inverters. We aren't making the claim that you can buy Selectria's Arcom box and use it with an SMA Central, for instance. We don't know that works well, so we don't recommend that. And I think that that's really where we're at, because there has been issue. We don't see a lot more people releasing products too early, too prematurely, without doing the sufficient testing. It's just taken a lot longer than I think the industry expected.
I think that's definitely good insight there, Claude. I know that's kind of a difficult question to answer, but did a good job. And we're right at 3 o'clock on the dot here, so let's just have some fun and ask one more, and then we'll definitely close it out. This is a good one, so I thought I'd throw it at you.
Okay.
It looks like the Arcom only comes in 16 or 24 string options. So will there be more options available for small string inverters like 4 strings?
So we currently have 8, 12, 16, and 24. And right now, we don't have plans to offer lower than that. And I don't know that there are too many situations where you would need smaller than an 8 for the way that these are typically deployed, because if you're working with 4 strings, you're probably not doing a commercial system. You might be doing maybe it's like commercial, but you're likely working with a TL, and the TL has the Arcom circuitry in it. So that's actually just a different product altogether. That is just essentially a rapid shutdown box.
All right. I think you're off the hook now, Claude, but thank you very much for all those excellent answers to the questions. I think that's all we do have time for, but I certainly did learn a lot. Hope everyone else did too. If we didn't get to your questions, or if you have additional ones, feel free to contact Claude on your own. I also believe Selectria will try to get to the questions that were not asked in the next couple of weeks, so you can expect a answer there too. But Claude, thank you again for being here. It's been really great to hear your expertise. Thank you so much.
And thank you.
We really do appreciate it. And thanks to everyone in our audience for listening and asking such great questions. We always appreciate your input. It makes for a great discussion. So I hope that everyone enjoyed the presentation, learned a little bit, and we do invite you to join us for more Solar Power World webinars. So thank you so much, everyone.